of Believe in Serverless Lunch and Learn. I'm really bad at PowerPoint, so please don't make fun of my slides. I'm just a CTO. I don't have to make things look pretty in general. So I want to talk about serverless observability. I'm going to get into just maybe some basic principles. And then the back half of the talk will be really kind of about how the place that I work, Kinesis Solutions, how we're a, almost like 99% serverless EHR. And you can ask me about the 1% later if you want. And I'll talk about how we do observability. Feel free to stop me. I'm like really informal. So if you want to stop me in the middle and ask a question, feel free to do that. If you want to wait till the end and like dog pod me, that's totally fine too. So, oops, why won't that go forward? There we go. So who am I? Real quick, the intro slide. If you don't know who I am, I'm Benjamen Pyle. You can call me Ben. I don't really go by Benjamin, even though that's like my usual name, because if you notice, my parents in the 70s got really crazy and don't know how to spell. And so actually a funny story this week, I set up a new email address somewhere and the person that set it up for me typed Benjamin and then misspelled my email address with an I. So like, you can call me either way and it's not going to bother me. So 25 years in software. I'm currently a CTO. I've been everything from an engineer and an architect and a developer. The only thing I have not been is QA. Thank the world for that because I'd be really bad at it. I've been a Scrum Master too, so that's kind of fun. Big believer in serverless first. I think we talked about this last time. I'm more of a serverless first than a serverless always. I have a consultant's heart and mind. Nothing is ever always and never. Kind of like the whole only Sith speaks in absolutes. So I try to stay away from those things. I prefer things to be compiled versus interpreted. If you see Ferris down here, that might give that away too. But I do like interpreted languages. I'm currently an AWS community builder. And like I said, I'm CTO at Kinesis. All right. So again, like classic agenda. So we're talking, what is observability? The observability Triforce, which I'm a big Legend of Zelda. So hopefully that resonates with some of you guys. Logs, metrics, traces. We're going to talk about how to observe an EHR in the serverless world. Maybe some things that I wish I knew, and then kind of taking some next steps. And like I said, you feel free to you don't have to use the chat or raise your hand. I'm really bad at paying attention to things in the peripheral. So yelling out stop is a good way to get my attention. So why observe serverless, right? So code is built, it's deployed, it runs, it fails. That's kind of the life cycle of where observability, most of us think that it comes into mind. And so we observe in order to understand why it fails, right? So just understanding that it fails is generally not going to be good enough, especially not when you have any kind of scale and you start mixing in event-driven and all kinds of things that go around with it. So basic observability can tell you when it failed, but advanced can tell you why. And the why is really, like I said, it's good to know that it did, but it's much better to know why or what's the driving factor behind it. So the observability Triforce, it's not wisdom, power, and courage. If you get that joke, that's awesome because, like I said, big Legend of Zelda fan. Logs, metrics, and traces, really in no particular order. Logs are, they're detailed or sometimes not detailed records that something occurred at some point during your operation. Everybody starts with logs, right? So we've all probably written console.out or system.println or something like that, or I can't remember what it is in C#, but we've all written something that dumps out to the standard output. And that's useful, can be. Metrics, numerical pieces of evidence, right? So you're basically counting things that happened in order to do something with it. And then traces. Traces are connecting the dots between operations that happen during the request lifecycle. So we'll get into a little bit more about how these relate together. Some people call them pillars. Like I said, I like Triforce because they all work in harmony. So with logs, most people think of logs as, like I said, you're new to programming, you're going to dump things to standard out, it's going to go to the console, and then like you get more advanced and you go to file, and then you realize that you're logging everything, and everything's going to this file, and now you're having to rotate the log, and then next thing you know, you've got millions and millions of messages, and they don't really mean a whole lot because there's no way to categorize them. So your next investment is in looking at log levels, right? And so log levels are basically just a hierarchy of an order and a way to be able to filter out what matters and what doesn't. So, I won't read through all of them, but trace is obviously the It's going to give you the most verbosity. Everything is going to get printed at tracing, and then all the way up to fatal. You're in a dumpster fire, and your code is panicking, and all of a sudden you're toast, right? So usually if you're going to operate in some kind of a scaled environment or even just in production, you're not going to set things to debug. I don't need to see, hey, I got here, well done. That might be useful locally. It might be useful, kind of at a development environment, but it's not going to be useful as you kind of work your way up the stack. And so log levels are kind of an advanced way that you can get into, no longer dumping straight to the console. Now you've got some filtering capabilities that you can tackle on top of it. Lambda and logs. So if we think about serverless, so I don't spend too much time on just like the basics of some of this, but Lambda and logs. There's two types of logs that you generally kind of see in Lambda. So if we take apart the log levels, I would describe those. These are my names. Like some people call them differently, and some of them also is, you may see this out in the internet, but it's kind of what I rally around, right? So application logs, those are things that you write. So if you've got a function that's executing and you want to debug out some information about the parameters that may have been passed into that function, I would call those application logs, right? So you're going to bring your logging framework. Generally, I'm going to prefer JSON over something custom because not like 5 years ago, actually, I'm going to pick something else. But now most logging aggregators are really good at JSON. They're also really easy to be able to read. You're going to include things like timestamps, source code, line, package, library, whatever you find to be useful in terms of figuring out. Because when that information gets printed from your Lambda, you're going to want to specify all the way down to, hey, it was in this function, not Lambda function, but the code function, and something happened, and you want to emit that. Request logs are another type of log that you're using already that you may or may not even realize you are using. And they're handled by Lambda by nature. You can customize them if you want to or write your own. But I like to think of, and this is a really simple approach, but old school access logs on steroids, right? So if you were looking at like a traditional web server, you're going to have request logs, or you're going to have just regular old logs, then you're going to have like an access log, which says that this IP address hit this endpoint. It's going to have some kind of timestamp that you can then determine how long the request took. In Lambda, this is, if you pay attention to it, it's got memory used, it's got a duration, it's going to have whether or not it was a cold start. You could get a little more fancy and emit things like, how many database queries it made. You could look at which customers maybe were impacted by this request. You could really kind of write this like summary log at the tail end of your function handler, which could help you do some aggregations on that request, right? So you could look at maybe you've got durations that are happening longer for certain customers versus others. So request logs can be really good for rolling up metrics at a later date. So they're a little bit different. So when you're in there writing your logging statements, so you're trying to figure out how am I going to instrument logs, inside of my Lambda. Application logs are things you're going to take care of. Request logs are things that Lambda is going to give you for free, but you can also then write your own if you want to in order to make something a little bit more powerful. So let me just double check here on the chat to make sure I'm in there. Got it. Yeah, that's right. They are called canonical logs. Yes, and Jason, not like Jason Wadsworth. Absolutely. I'm going to keep the chat up over here so I pay attention. So metrics, like I said, metrics are counts and sums. So think about metrics and averages and all kinds of different things you can do. At its very, very basic level, these came straight off of the, I'm going to hide that too. They came right up off of the Lambda console. So I grabbed these screenshots. This is a pretty simple Lambda that you can see. It's 4:15 in the afternoon and had a count of like 15, 16 invocations that were going on. You can look at duration, right? And so nice thing is this is actually breaking up duration by minimum, maximum, and average. So you pay attention to these things, really kind of at a count, sum, average, some kind of level. A lot of times, and when we get further in the talk, we'll see metrics are a lot of times where I start. I'll walk you through my debug process, and it's not right or wrong. It's just the way I like to look at it. But metrics are usually the place that I like to start when I'm doing any kind of troubleshooting. So common ones you're going to look at: duration, invocations, success, error, whether or not you were throttled, right? Those are all kind of useful things. Oops. Here we go. A little bit deeper. And one thing that I think is when you're starting to really kind of get into beyond the basics, using the defaults are great. But I like to explore deeper use cases. So I didn't highlight specific ones for my workloads, but if you think about it, like what if your product team is like, what's the average cart size per request from, I don't know, the Pacific Northwest? Or what's the latency that we're seeing based upon users that are coming from the Midwest in the month of June, right? Or maybe it's feature utilization. So the interesting thing about metrics is that you can really begin to add dimensionality to those items, and so that you can use them to further refine what it is that you're trying to accomplish. I think a lot of times people focus on duration and latency. I mean, you've heard me talk about cold starts quite a bit, but it's really just kind of, just scratching the surface of what you should pay attention to. And the same thing for success or failure. It's a great starting point. But the nice thing about metrics is that if you really start to understand your business use cases, you start to dig a little bit deeper, and it helps you tell a bigger story. Because if I was to call, an engineer in the afternoon and say, looks like this API is really having a hard time. I think it's down based upon the error percentage. But what if it's only down for like a locality? Or what if it's only down for a specific customer population? You really want to try to get as specific as you can when putting some of this stuff together. Then to round out, or to triangle out the Triforce, traces. So I wanted to kind of highlight a little bit of this, is that think about your trace as kind of like what it sounds. It's like you're literally tracing the flow of your request pipeline. And your request could be coming from an API endpoint. It could be coming from a Kinesis stream. It could be coming from DynamoDB. At whatever point the initial triggering of that item or that request happens, what you want to be able to do is you want to be able to use this context in order to pass around throughout the other services, so that you can start to then look at metrics inside of those spans, right? And then you can also further connect those spans into those log requests. And so if you were looking and going, I want to see, maybe I have to identify that a customer in the Pacific Northwest seems to be having a real hard time with performance, I can trace that down. And if I've got 3 teams working on service A, service B, service C, every team is going to go, well, it's not my service. Well, service B might be the one right here in this op that's causing the problem, right? And there's no way to really see that very well unless you're connecting those traces. And so there's a lot of really, really, really impactful stuff that you can do when you're able to connect the dots between A, B, C, and D. So this is something that I find that when people really start getting going with managing observability, they get that initial trace, but when it's not connected across the boundaries that thing may touch, you really haven't realized all of its full potential. One more thing of note here is that when you're looking at starting these requests and traces, it's best to start it at the top level. So for a scenario like maybe I'm on a shopping cart application and I'm going to click order, I want to originate that unique identifier, which when I say request ID, it could be if you're in the .NET world, it's a GUID, right? If you're in the non-.NET world, it's a unique ID. If you're using a KS or a sortable ID, right? Whatever it is, I would start the request ID process at the client side. And then what you do is you carry that request ID, which is also sometimes called a correlation ID, throughout each of these components, so that if the request came in from the top from the API, you would know at the UI level that this is where this originated from, and you could see all the browser details attached to it, and then you could trace it through the services. And maybe you were doing some event-driven things, and you've got an event that's going to get picked up somewhere else. So it's super powerful when you're tying all the dots together. And I would argue that if you're not connecting all the dots that way, it can be really difficult to identify that needle in the haystack. And once you get beyond the ability to see 10 users connecting at a time, if you've got 1 million events happening over an hour or over a day or over 2 days, it's next to impossible to find the proverbial needle in the haystack. Another kind of just pro tip that I didn't realize early on that we could do, and this is something that we have not implemented at Coronis, so I didn't put it in the EHR component of it, but I think it's helpful. If you can even orient your customers, right? Like let's say that something bad happens. If you can orient your customers over supplying the request ID, like you could print it out in the error message, right? Hey, sorry, something bad happened. if you're going to contact support, here's this ID that you should pass along. If you can build that level of trainability into your user base, then when a support ticket comes in, it becomes pretty straightforward to go find. You can almost work bottoms up, right? Find the logs, find the traces. You don't even need the metrics at some level to be able to identify that beyond tracking down the errors. So correlation or request IDs become super important. And again, starting from the front end is great. If your thing is event driven, start from wherever the beginning of the process originates. That way you've got maximum visibility throughout the pipeline. I'm going to check the chat. There we go. Yeah, it can be. Very true. I like that. Good point, David. We should have co-done this together. That would have been fun. David's got a lot of really, 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 really good insight into observability. All right. So any questions before I go to the next slide? Any questions? Anybody want to stop? Grab a glass of water? Ask anything about it? Crap, I'm really bad at this. All right, super. So we're going to dive into the EHR. And for disclosure, so Kinesis is an electronic health record. For those of you not in the United States, the United States healthcare system has regulations around portability in their health record, security in their health record. It's got really, really tight standards. And then for further transparency, I'm currently a Datadog customer. So a lot of these screenshots that I've got in the slides will be of Datadog, but I will talk about them as with as little bias as possible, although I do believe it's a really good product. So with that said, and I don't get paid to say that, by the way. So with that said, Kinesis is an EHR. We are 100% AWS. We have never known a data center. We have been in the cloud since the beginning. I've been here for 6 years. We are, like I said, 99% serverless. In about like 6 months, I expect us to be 100% serverless. It is a mixture of Fargate and Lambda. I say 99% serverless. I got to back off that because RDS is not all the way there. But yeah, it's a large mixture of RDS and DynamoDB. So imagine a world where there is a health record that is in the cloud and it's cloud native and it's got a lot of events and it's got a lot of APIs. And what do we do with it? So we keep track of patient and clinical documentation, right? And so that documentation, we've got, without divulging too much about the architecture, it's highly distributed and highly disparate, right? Like we've got kind of pretty quote unquote pure microservices where every boundary has its own API and its own data store. So nothing talks to anything except through API or through event replication. And we have a lot of use cases that are wrapped around the idea of having a single view of the patient record, right? So if you think about a patient, they're going to have medications, they're going to have encounters, they're going to have visits, they're going to have documentation. But if every service only has a fraction of that, you never really have a full view of that patient except in one place. That place is in Amazon's Health Lake. I could spend an hour just on Health Lake, but if you're interested in that service, go take a look. It's fantastic. It would be serverless if it didn't have a compute minimum, which back to our first lunch and learn with our serverless definition, but it is super, super close. It's like Elastic Cache serverless. It's almost there. And it's a fantastic service. So our use case must support over millions of events a day. We have built the workload. It is serverless. It's Dynamo, Lambda, step functions, and Kinesis that are kind of baked in there. And then each patient entity requires its own transformation workflow based on the design that I was talking about. So it looks like this. Each one of our microservices in its data store. And I took the Dynamo sample because I didn't want to explain. If you've never used DMS with RDS before, it's an interesting experience. But the DynamoDB stream is super straightforward. And for the most part, this is an oversimplified version of what takes place. But as data changes, it's streamed. It goes to Lambdas and step functions, and I just use Lambda for the diagram. It's ultimately outputted into Kinesis in a prepackaged fast healthcare interoperable resource format. And then we have one Lambda that manages the interaction between Health Lake and Kinesis. It's called, very funnily, the Fire Consumer. Oh yeah, multiple tables. I'm a single table first guy, but not a single table only guy. Where's Pete and Alex? So anyway, yes. So this is kind of the overarching workflow. So as you can imagine, data is changing all the time. How in the world am I going to keep track of what's actually taking place in each one of these pieces? And again, stop me if you want me to dig into anything else any further, but we're going to get into metrics. So we use metrics very specifically to understand how well things are succeeding, right? So most of our metrics are organized by, we call tenant, we're in a multi-tenant environment, or they're ordered by patient. So you want to kind of pick with some of these things, right? High cardinality. I want to get a lot of reuse out of the same things. And so metrics that we really pay attention to identify latency, they identify performance. There's not a ton of things like basket size or payload size or any of that, but we do pay a lot of attention to depth of queues for reasons that, if you've got high depth of queue, you may have latency in processing. If you've got high depth of queue and a dead letter queue, you got lots of errors. We're paying attention to that Kinesis stream quite a bit to make sure that we've got the right amount of shards in place, and that we're not overextending the number that we have. And so we really pay a lot of attention to that pipeline to manage, how well the health. And like I said, I use metrics a lot in my day-to-day as almost an indicator of health in a lot of ways. And so the team that's paying attention to this in production is using those metrics to carve those pieces up. So this is some examples of some of the things that we look at. So this is a Lambda that's actually, I forget what this one's doing. This is one that's actually pulling data and populating around the encounter resource. And so the encounters are doctor visits, things of that nature. Take a pause for this. Oh, yeah, we do. So good point, David. The metrics, but so we do. We use these as we're getting into paying attention to things like errors, right? So if you look at this, we're obviously throwing errors at greater than 100 over that period of time. Metrics tie greatly into what David was saying, which are alarms. Those alarms trigger action, right? And in our case, these trigger over into Slack. So Datadog will post into Slack. We've got thresholds around what's acceptable, what's not acceptable. And then those alarms going into Slack, the teams can take action. Again, very specific over what we're working on. But in this scenario, we've got requests and errors. These are just simple counts of what's happening. We could look at latency if we wanted to. And then this is just a graph that shows where the latency is spent, or the time, or the duration, I should say, is spent when during an individual process. And so this is kind of interesting because this pipeline is actually back to that original diagram. This is service A, service B, and service C. Both of these services are, I know this, these are Java services. They're running an ECS. They're connected to Postgres. So you can see that we spend some time in this middle band, and then the rest of the latency is generally, or the timing is spent around Postgres. So if this was anything that was out of whack, again, these are just percentages. This doesn't tell me this could be, 100% of 10 milliseconds. It could be 100% of 5 minutes. If the purple band was at a severe enough level and the duration was high, then obviously this would necessitate some more engagement around it. But these are actual metrics that are being tracked through the system. There we go. Here we go. Oh, yeah. So I don't quite follow. Do you want to speak up, Ryan, or do you want me to guess?
No, just sometimes like events have to fire multiple times. I'm just maybe it doesn't matter in this case. I was just curious if
Well,
you're handling that case, like duplicates.
yeah. So most everything, at least our architecture guidance is to prepare everything around being idempotent, right? I want everybody to treat the event as if it might come twice or 3 times or 4 times or whatever it is. So any operation that they're performing should be non-destructive in that regard. Now, if it's something that might be destructive, then they handle that code inside of their application to be able to treat that as having seen a duplicate. But it really just depends. We don't do any FIFO queuing, so I have no guarantees of singles throughout this platform. I don't think we use FIFO queues. Rakesh could keep me honest. He's on this call. But yeah, most everybody is doing that. Now, we have seen, as we were early on in our build of using this stuff, like, yeah, we saw it. You get the same record in the database twice because somebody wasn't paying attention. But yeah, absolutely. So another way to think about metrics, and kind of going back to, again, if I was looking at this graph and not really seeing it from the big picture, what does this kind of look like? And this is another function that we've got that is processing the interaction between the health lake, right? So a couple things that I generally like to look at in these latency breakdowns are, in this case, this is an interesting trough right here, our trough that's kind of going on. Normally, I would probably be, that's something strange, but actually what's going on is this is pulling batches and the busyness of the function. So sometimes it's only got a couple in the batch. Sometimes it's got, more than a couple in the batch. And so as you can tell, most of our load falls in this more than one. And then all the way out on the tail end, what I do like about this is that the tail is not super far. But again, where these tails do come into play is I know that it's the batch is larger. So I think in this case, this can pull, I think, 100 records from Kinesis. And so most of them fall in this same band of, half a second to a second and a half. But we do have some stragglers that kind of fall out. So again, it really kind of, metrics alone don't really tell the story. If I was to show this to somebody who wasn't involved, they might have some interesting thoughts on it. But if you know what's actually going on, which is kind of where the dimensionality of some of your tracing or if some of your counts come into play, and understanding exactly what you're paying attention to. So for us, we pay attention to how things are performing. I generally want to see a nice kind of tight grouping in the P95 or less. These outliers would be a little concerning, but like I said, I know they're driven largely by batch size. So EHR traces and spans. So I mentioned earlier the helpfulness of traces and spans. This was something that, when you come from writing, I don't want to call it the monolith, but when you come from writing like single process applications, it's pretty easy. You always don't connect these. You used to not connect these dots, right? Like I would have logs that would have an ID, and I could trace it all through. I could aggregate my logs, and it was good enough. With having this distributed system, being able to keep track of what services might be called, what services are operating, how long things are taking, what's the failure across those boundaries. Traces and spans really help to kind of connect those dots. And so one of the nice things, depending upon how well you do some of this, is that you can tackle, it's not just function to function or API to API. You can instrument the AWS SDK, which is fantastic because then you can see how long a Dynamo query ran. If you saw the tweet I put out last night, I instrumented Memento, and you can see how long the Memento cache is taking, which by the way, it was like less than 3 milliseconds, which is super cool. And you can really start to break apart what operations inside your code are doing what. So, more chat. There you go. I like that. Visualize logs. Kind of a good way to think about it. And so none of this stuff comes for free, and we'll talk a little more about it later. But the real trick to observability and to having the level of detail that you require is 100% around patterns and architecture and discipline. It is not technically hard. And I mean that with like all the level of all the problems you're going to solve in a serverless application, logs, traces, and spans. Once you get beyond the tooling and the SDK you use, it's not difficult. It's literally about making sure that you're doing things correctly and you're thinking about what you want to capture. So that mindset of really kind of working backwards from what are the things I want to visualize or what are the things that I want to see, and then being able to do that. I tend to use the same type of dimensions that I do in my metrics. I'll do them in my spans as well, depending on if your tool or your vendor supports it. So I find that to be super helpful. Looking at one of those, so this is a visualization of a trace. So I showed you my lucid diagram earlier of what that would look like. This is one of those Lambdas and one of those pipelines that's inside of that encounter context. And so this encounter context requires data from our patient, and it requires data from our visit pipeline. So it is literally spanning multiple service boundaries. Think of the trace as the root, right? It's the initial request that's coming in. Spans then link to traces. And like I mentioned earlier, spans context might stretch across service boundaries. So if you look at the total request of this is 24 milliseconds, the bulk of this is spent waiting right? So it's IO. We're waiting on web request, and we're waiting on query request in order to accomplish. And yes, that is some Java stuff that's being emitted there. So it's kind of the nice thing is too, is that just because I think this handler was written in Go, the other two services were written in Java, you don't talk to each other over any of that language boundary. You're talking over, in this case, this is talking over Datadog's SDK, but you could do something with OTel like WC3 traces and their trace header to be able to connect those dots if you want to be super open standards, which we'll talk a little more at the end. So traces and spans. I love David's visualized logs. I think that's fantastic. But let's see where we can go a little bit deeper with those. So one of the nice things about Datadog specifically is back to the fact that I could have some Postgres that's going on, could have Dynamo, could have something else. If you're able to take a peek at what's actually being executed, and the queries don't have the actual values, there's no PHI or any of that stuff in here. But if you have something that looks like this, and you know that you've got some SQL buried in here somewhere, then you know that you can take an inspection as to look at what's going on and how long it's taking. We'll give you two really good use cases that this has helped us several times. One of them was like 90 days ago. We had one endpoint out of a service that was timing out, was passing the API gateway 30-second timeout, and team was really struggling with what it was. Well, somebody who's on this call went and took a look at it, and come to find out that the 30-second timeout was because the Postgres query was not coming back inside of 30 seconds. And a simple index, I think 3 indexes, put on a couple of tables. Next thing you know, the thing ran in like 10 milliseconds. So being able to quickly identify that traffic coming from the top into the service, seeing that this service was erroring out, not across every endpoint. It's got, I think the service like 10 endpoints. The one endpoint was the only one that was having trouble. And it was that one endpoint that was leveraging that one query, and that one query was causing a problem. Another thing that I think you'll find, and I've seen another really interesting piece is, this is kind of why, and I'll go on the record since this is recorded, I can't stand object relational mapping. I just really don't like it. I really don't like the way Java and JPA does it. I don't like it. I don't like it. I don't like it. And I've seen it produce the N1 problem over and over and over and over and over and over. And so when you're running things and you're going, man, why are things taking so long? And you go look, and I have one endpoint, and one endpoint runs 1,800 queries, which you can see if you're tracing through your application, then it's pretty straightforward to go, oh goodness, I've got something going on. And if I can see that in dev versus waiting to see that in production, I've just saved myself a whole bunch of headache. So this whole process can be used even inside of your development environment. Yeah, I agree with Jason. I knew I had a friend. Don't tell anybody I said that, Rakesh, about Java. So how do we use logs? So the electronic health record and logs. So logging to log is wasteful. Like I have an example down here. Something happened. Like that's great. Like if you really want to know that, use your debugger, or for the love of all things that are cost sensitive, make it a trace log. And generally I don't see people running in environments with trace. So hopefully you're running make it a trace statement. And then at least when you get to dev and QA and prod, that'll never show up. But so logs are always attached to traces at Carantis. Logs and spans are always grouped together. I'll show you a little bit what that looks like in a second. They're always grouped by error level. We don't do any system.out.println line. There's no console.log. None of that stuff going on. Logs are dimensioned by patient, tenant, or whatever else that we've got going on, again, to be able to work our way down and filter. But remember, if you're able to grab the request ID, dimensioning logs is interesting, but I don't find them as useful because I'm usually looking top down at metrics that are dimensioned. If I already have the request ID, I really don't need the other details to find and search. So it really kind of depends upon kind of what your environment is. Logs are the why, right? Why are things going wrong? Like they generally are not the starting point. Like I said, unless you have the peer request ID attached to it, they're really those specific details that are happening inside of your application code to tell you exactly what's happening at that point in time. Here were the parameters, here was the operation I was attempting, all of those pieces of data that are helpful. So logs should not be generic, especially not useful ones. So like something happens, a bad log statement, unless it's a trace. Key not found exception, right? That's a really good statement, in my opinion, because I can go, oh gosh, we're having a hard time. It didn't find the key. Why not? And then I can further expound from that. So being specific about your log statements is going to be helpful to you. So inspecting what happens, this is actually something from Datadog. And this is a trace with some spans. Those spans, this is a really bad log right here. That should have been a trace, but these are debugged because they're gray. So maybe it's okay. And this is a really good log statement. So if I'm looking to figure out why code didn't execute versus something else, patient has yet to be admitted, aborting reprocessing. That's actually not a bad log statement, right? And so those logs are connected to those spans and traces. So I can go take a look and say, all right, let me figure out what's going on, and I can connect those dots. And hopefully your tooling's pretty good at connecting those together. No, I'm here. Those are great. All right. Any questions about logs and traces and kind of connecting? Sampling. If you've ever had to write a check for logs, please sample. I don't ever sample error logs generally, because I feel like error logs, they should have done correctly. Error and fatal logs are something that I never want to throw away or put to cold storage. But I try to sample where I can. And then my best practice we do at Qantas is we try to break apart indexes by log level and environment to keep things a little bit cleaner. And then you can search across indexes, but really kind of a way to help filter down what some of the noise. But sampling is super important. Sampling can be the same thing for traces as well. So for if you're tooling, so for Datadog, for instance, you can sample traces. It'll help maintain cost at some level. All right, so let's go a little bit further. How else could we use some of this? So looking at Lambda, which I spent most of the talk talking about Lambda, and in a serverless application, we have more than Lambda, right? Like Lambda is not serverless, or they're not analogous. So we use state machines, step functions, and Kinesis, and a whole lot of other things. If I start to really take apart, and I could go further into really digging through traces and logs of all these things, but at a very top level, if you're going to operate something that's going to scale beyond one user, you're going to want to pay attention to top level metrics that come out of these. Are just straight from CloudWatch. I didn't even pull them from Datadog, but you're going to want to pay attention to it, right? Execution started, succeeded, yes. Errors, 100% yes. Depending upon what I'm doing, duration matters. And Rakesh keeps track of costs, so he pays attention to build duration. But it's super important. The duration matters depending upon the context. Same thing for Kinesis, right? So I think this was the dev queue, so there's not a lot of traffic. But really, really, really important thing, iterator age. I once worked at a place that thought that Kinesis wasn't performant because it took a day for data to be processed. Well, the real reason was they had flooded their downstream system, and data was taking a day to work its way through the platform. So more data was being brought in than can be pulled out. And Kinesis was doing its job, but then they were losing data because they had a 24-hour horizon window. So paying attention to iterator age is important. Iterator age is also a really good telltale sign. If you don't have high consumption to where you're putting data faster than you can read it, you may have a poison pill buried inside of your Kinesis stream. Kinesis does not work like SQS, right, where you can fail it and dump it into a dead letter queue. There are ways to do that, but it's not naturally going to be attached and do it. So if you see yourself building an iterator age up and it's not based on the fact that you can't process faster than you can consume it, or then you're writing it in, you may have a poison pill. And so if you have that problem, I can help you with some medicine on that one. So anyway, so we pay attention to a lot of different metrics that are sitting on top of the EHR so that we're watching these data flows. Yeah.
Hey, Ben, before you move on, can you explain to everyone what a poison pill is?
Yes, it's all right. I won't even try to make a joke. So anyway, poison pill. So let's say, like I said, if you've got a message let's take a simple example. So I'm writing data into Kinesis and my consumer expects a certain payload. And I had a bad producer that wrote the wrong payload. And my consumer is basically sitting there trying to unmarshal that payload or marshal it into an object. And it keeps failing over and over and over and over. That message will just keep failing, keep failing, keep failing. Everything that's behind it is just going to start stacking up in your stream. So the way to deal with that is to try to bisect that on failure, and you can separate out. And so you can physically kind of work your way down almost like a binary search to figure out where that poison pill, where that bad message was. And then you can throw that message into a dead letter queue, but then continue to process the rest of your messages. But Kinesis will not, like, you can't just say after 5 retries, or not as cleanly as you can in SQS, 5 retries and it's going to go to a DLQ. You've got to be a little more intentional. And it's almost like, here's something. It's like a beaver put a dam right in the middle of a river. No more water's coming through. Tried to use the otter thing, but otters don't build dams as well as beavers. Good question. Thanks, Alan. All right, so gonna move on a little bit further. All right, so here's how I like to think about this. So, and again, my brain is weird. I've told a joke about pterodactyls and peeing. I've talked about otters, beavers, and dams. Like, you don't have to follow my process. This is just literally how I think about things. And so in the absence of not having logs coming upstream, and then I have the correlation ID, the request ID, I almost all the time, I spend most of my time looking at metrics. That's why the metrics are large at the top, right? What's kind of happening? What's the success? What's failure? What's latency? What's maybe, what's average car? Well, whatever the thing is that you're paying attention to, that's generally where I start. If back to that whole indexing thing, I can look at metrics by endpoint and say that one's performing bad. Why is that bad? I found something the other day. There was a 1.5 Dynamo. One of the endpoints was taking a P99 of a 1.5 on a DynamoDB get. I think it was a get. No, it was, I forget what it was. It was really not good. And so like those things start to stand out to me. They were probably trying to do single table, but it stands out to me at a high level. And so using metrics are a really good place to start. And then I work my way into traces because I go, okay, great. I've got these metrics. I've got this one endpoint that's performing poorly. Let me go look at traces. I can then filter traces by success or by failure. I can filter traces by latency. I can filter traces by, was it a web call, a Dynamo call, a SQS call? Was it a whatever it was? I can start to really kind of narrow my scope down at what I'm looking at. And then finally, I can then go, okay, well, do I have any logs that help tie the picture together? Oh, there's an exception. I tried to unmarshal some bad data. Or, oh, there's a database failure because I ran out of connections, right? Because I did a good connection. Or, oh, I tried to look up a key that didn't exist. You know what I mean? So starting top level, I'm watching the health, I'm working my way through traces, and then I'm getting to the logs. And if I've done my dimensionality and my correlation correctly, I mean, Rakesh can keep me honest here. There's generally not a lot of problems that we can't figure out what's going on in a reasonable amount of time. And as somebody that's troubleshot everything from a mainframe to a C-based billing system to .NET, Java, Go, Node, TypeScript, like when you're under pressure and the customer is asking you for something, having a process to work your way down to finding out what's going on and being able to rule out what's in and what's out in a non-heated but logical approach gives you a leg up, right? And you've kind of got a routine and a pattern to go after. So this is 100% the way I think about it. That's right. Can you stream? Yeah, that works. I can see that working too. David always has the coolest ideas. I'm not even kidding. Like he does stuff and I'm like, I didn't even think about it like that. So anyway, this is kind of my process. So this is the way I think about tying everything together. It's how Kinesis works as well in a lot of ways. And so things I wish I knew. I wrote a series over the summer about this, like things I wish I knew when I started serverless. It's like a 6-part series. And so this is like what I wish I knew. And I'm going to read these and you can, whatever. But observability is accomplished through standards and discipline. I 100% believe that. I will probably argue that point with you if you didn't agree with it. I had this conversation with some people at dinner on Tuesday or Wednesday night. And I'm like, once you pick your tooling, it's really not that hard. But needs to go into your pull request process. Your team leads need to get it. Your product people need to get it. You know, it's not free either, right? Like I had this conversation yesterday with product. If you want me to observe things, which is what I'm going to require us to do, it's going to take story points in my sprint. And since I'm CTO, I can say that that's okay. But like if you have to make that argument upstream to management, then it does. It's going to take points, but it 100% worth it. Open telemetry has promise, but it is not a silver bullet. This is probably coming more from my leanings with Rust and open telemetry and Datadog. If you're sticking kind of down the TypeScript, Python, .NET, Java world, you have options with AWS's open telemetry distribution. You also have options with your vendor. Baseline and Boris and those guys do a great job at collecting OTel traces. There's a lot of magic that's built into some TypeScript libraries if you're using those. So it may be more on my like my rustiness that gets me into trouble, but open telemetry's got its good and its bad. There's a lot of things that kind of go into it. If you're valuing openness and portability, it's probably worth the pain, which leans into my next one. Leaning into vendor lock-in might be your best option. And the reason I say this is because if you want the richest and deepest of experiences, it's kind of like AWS, right? Like I can run on EC2, but if I want a really rich experience, I should probably just use step functions and Lambda and use their SDK. I mean, I could write HTTP calls and V4 sign them myself. Why? But why? It's kind of that. So it really depends. You need to evaluate that. I feel pretty strongly about, I don't mind the lock-in at the observability layer, but I completely understand the point around portability. And so I've had better integration with tighter alignment to Datadog than I have with being open telemetry based. And I know like if you look at some of the other vendors, they have really good libraries and SDKs that you can look around as well. So defining log levels and enforce indexing based upon levels. Yeah, I wish I knew that like that would have been a good organization tip. We used to do that at the fat server level, but it makes a lot of sense and is easy to filter out your logging. Like I said, sample, sample, sample. It gets expensive. Pay attention to retention periods. So if your vendor truncates data or you've got a CloudWatch log group that you're getting rid of in 24 hours, you know, you're going to lose that data. And maybe you don't want to lose that data. So pay attention to that. Do the work, connect your tracing, spans, and logs. Again, it'll be story points, and your manager or your director or your team lead may say, oh, I don't want to do that. But like, I promise you, it will help you at some point. And to do the work, to be able to solve a critical production issue by just adding an index inside of 5 minutes of figuring out what caused it was worth the time and effort we spent putting the index or putting the instrumentation together. Dive deep beyond the obvious. May seem like something obvious, but top level metrics, top level traces are great. But figure out how to instrument beyond that. And again, open telemetry can do this. Your vendor's SDK can do this, but instrument. Do what you need to do in order to be able to observe what you need to observe. And again, dimensions and then high cardinality to gain maximum flexibility. Try to use things that are reusable across different queries and different looks. Next steps, and I think this is my last slide with exactly 5 minutes to go. So again, work backwards. Identify what matters. And for me, it's patience and tenants. For you, it might be, you know, I don't know, rainbows and unicorns. I have no idea. But the important thing is that you figure out what you want to monitor, how you want it to look, then go about, you know, who do I choose and what do I pick and all that stuff. Thinking about how this would look in the right scenario is really, really, really important, right? Evaluate metrics beyond the built-in. This can be super helpful. Vendor choice. I used AI to generate these icons. I don't know why I picked a beehive, but so vendor choice. AWS will serve you well. I guess it was because of the honeycomb piece. You can use CloudWatch and X-Ray and Insights and, you know, use the basic metrics and CloudWatch alarms and all that. It'll get you what you need to get to. I mean, I'm not a huge fan of it, but it will serve your purposes. So if you don't want to get outside and start looking around, start with AWS. Beyond that, like my personal faves, I like Datadog. I love what Boris is doing at Baseline. I like Honeycomb. There's lots of places to look. Those are kind of the three that I like. But like, I'm just one guy sitting in an office north of Fort Worth. I'm sure there's lots of others, and as long as you're doing it is more important than the vendor you choose, I think. Open Telemetry is a growing standard. Get out and look into it, right? Good support for Node, Java, Go, and C#. Good support for Rust, but documentation's improving. If it's interesting to you, collaborate on it. There's a lot of projects that are out there. You can jump in, you can get engaged. It's open source. Be flexible in observability collection. There's nothing wrong with any of it, right? Doing a centralized approach, a sidecar approach, or a Lambda layered approach. There's different ways to do it, and you're still going to gain the output. It just depends how you want to operate it. The last thing I would add that I didn't put on here is don't wait till you can do everything to get started, right? So if you're in a monolith, it'd be pretty cool to start observing the monolith. You could probably get a lot of bang for your buck. If you're distributed, start with one service, right? One boundary, one set of functions, one container, and go from there. Build some small wins. The entire movement to serverless or moving toward another architecture doesn't have to be an all or nothing. Keep your end goal in mind, work backwards, and start small. Show progress, show wins. I promise you, people like me who write checks are like, cool, I see benefit. My team is less time to complete a defect, less time to troubleshoot something in production, less time working on the weekends. I'm a huge believer in sustainability of resources. That includes human time. I only want people working 40 hours. And observability is a great way to be able to keep workload under wraps. Yes, don't let perfect be the enemy of good. I agree with that. And that's it. That's all I got. That is my my walkthrough observability, EHRs, jokes, everything else. So any questions? Except from David, because he's going to ask me something really hard.
Okay, so earlier you said don't sample error logs. Are you implying collect all the error logs instead?
Yeah, I like to. I kind of look at it like this. The samplers are usually really good, but I'd hate to miss something. And I feel like errors and fatals, they don't happen a lot, so my costs aren't going to go crazy, right? Unless somebody like accidentally makes a bunch of debug statements and mark them error to kind of like game the system, which would be pretty crappy. But I generally like to hang on to as much of the error and fatal data as I can. That's just a personal opinion.
One of the things I always like to make sure that we clarify for people that aren't as advanced in a particular topic is making sure we define everything. Can you just define what sample means when we're talking about observability?
Yeah. That's a great question. Sampling is just taking a portion of those traces or logs and maintaining them in like a live retention period. So if I'm sending 1,000 requests to an endpoint, I may sample 10% of those. So I get 100 out of every 1,000, right? And generally with vendors, you're going to pay based upon data sent, right? That makes a lot of sense. And so if I can send, 1/10 of the data, I can maintain my costs. I like to try to make sure I understand how good the vendor sampling is. So I'm not missing anything, but generally they do a pretty good job of balancing it out. So you're catching a nice blend of errors and failures and success, et cetera, et cetera. Excellent. Rakesh left. Oh, there he is. What do you want to ask me about crime? Like, I felt like you were going to throw me a curveball, like Rakesh. So you don't know, Rakesh and I work together, and I was like waiting for him to throw like some really hard question.
Wow, wow. This is very good one. Super nice.
I have another one.
Yes. I love
It's something you didn't talk about, which is actually surprising to me. Can you talk about observability and how you can be proactive versus reactive, one or the other?
Yeah. Yeah. David mentioned a little bit of this. Using alarms, right, is a connective piece that you can start to get ahead of trends. And again, going back to metrics, could be counting of logs, it could be metrics and operations. If you start to see a growing trend of failure in an endpoint, so let's say that out of every 100, 5 failures is too many. I might throw a warning as I get to 2. And a warn might go to the channel. And we use Slack and, oh gosh, the AWS and the AWS chatbot, that's what it was, to connect the dots between Datadog and Slack. And so at like 2%, we may throw a warning alarm that goes to a distro. That way people can go get out and take a look. And then as that grows, the severity grows. And then as that bad condition starts to subside, we can then start to say, okay, we're all good, or the warn's all good. But using monitors are a nice way, or alarms, to be able to do that. They also can even come in handy if you run a lot of containers. Daryl, I think, was mentioning this the other day. I think it was. But you know, as you're scaling, right? Like you're using CPU or traffic or whatever else to drive scaling. So it's not just even alarms. It also can start to do preventative type things to heal or gather or get more information on. I don't know why I left that out. I don't put them as part of the Triforce. I need to come up with a Zelda version of alarms and what that character might be.
I could probably add a couple of things there. I mean, you
Yeah.
don't really know what good logging looks like until you've been burned a couple of times. And so
Good point.
I think we could probably send a bunch of links about here's exactly what you need to log in every request log, like your stack trace,
Yeah.
all these kinds of things. Well, we could probably send out a couple of things in Discord. But I think to add to what you said about setting alarms is another thing that helps is a really robust culture around looking at your dashboards every week.
Yeah.
So you start to discover very interesting things if you've been watching something for a while. And then you can say, oh, that looks odd. Let me dig into that. And then, oh, I'm missing an alarm here. I need to add an alarm. And just kind of wallow around occasionally and go deep and try and figure out what's going on. So I think that's an important part of a culture. Like when you're just starting, you just kind of look at the logs and you go down line by line in the logs. But then once you realize, oh, there's better and better ways, and instead of starting at the log, you're looking at your graph and you're drilling into it, and then eventually like summarizing it, finding the highest latency requests, and then drilling into those. Like once you get good at it, there's a lot of best practices, and I think we could probably send a bunch of links from some of the people who are extremely good at doing this, have been doing it for a long time, that would really help if you're getting started.
No, it's great. I think you're spot on, because I mean, the term alarm fatigue, right, can happen if you get too many things. If you're not paying attention to what matters, then nothing gets squared away, right? It's really difficult to do that. I've seen teams be really good about what you just said. They would pick off slow performers, bad performers, and bring them into their sprint, right? And we're talking like, if you've got a company standard or a team standard of like sub 2-second latencies for all requests, they might be picking off 1.25 seconds because they're like, I can squeeze a little bit more out, and they're really focused on customer experience, service engagement, resource consumption. You know, as your culture starts to get around that, I've rarely ever seen a culture go the other way where they got so into it that they were shaving like 2 milliseconds off of something. It never goes that far. I've never seen that, but that's like an anti-pattern. But culture is super important, and the discipline around making sure that you're observing it and tracing it and putting it into your code is a point that I think should be like quadruple underscored.
And I think one other thing is you showed that graph where the batch sizes were different sizes, and what's tricky about a graph like that is then a lot of stuff can hide. So it's best to omit one metric per request instead of one metric towards a varying batch size, so that like none of that stuff can hide in there.
Yes, it's a good point. Hiding metrics. Any other questions?
Oh, we're over time. So
sorry. No, you're shutting us off. You're like it's like the semisonic Alan closing time.
Get it out of here. Had I seen, I would have cut David off too. So
well, thank you all so much. Do you want to tease next week? Excited for next week.
Yes. I don't know how to say his first or last name correctly, so we're just gonna take what I say with a grain of salt. If he watches this recording, I apologize. Marcin Sodkiewicz. Oh, nailed that.
That's pretty
He
close.
is
Okay.
a principal engineer at Ryanair, which is one of the largest airlines in Europe. He's going to be talking to us about their serverless journey. So they've just completed a relatively large migration inside of Ryanair. So he's going to come in and tell us the pros and cons of the trade-offs that they made and what happened on the other side of it. So I'm actually really excited about that one.
Yay.